Okay, the hardest part about this chapter is that you've now learned your basic derivatives and your basic integration. Well, this chapter broadens both of those. So basically, we're going to learn how to take the derivative of some kinds of functions, and then we're going to turn around and learn how to integrate those same functions. So that's what we're doing with natural log. We learned how to take the derivative of natural logs last. Now we're going to integrate using a natural log. All right, so recall that the derivative of the natural log of u is 1 over u and then times du, or times u prime. So if we have 1 over x dx, its integral should be the natural log of x. So just the opposite of what we've been doing. All right, there is an absolute value that's thrown in there. And the reason for that is that when you introduce a natural log to a problem, it may change the domain of the problem because the domain of natural log has to be positive. So all you have to remember is just put the argument of the natural log in absolute values, and you'll be just fine. If it's just 1 over x dx, then the integral is the natural log of x. However, it could be a little bit more complicated, and that is you've got something on the bottom, and we're going to call that u. Well, as long as the derivative of that is up on top, then the integral would be the natural log of u, or absolute value of u. So let me just kind of, or Tamara, go ahead and ask your question. Yeah, we're going to use U-Substitution for this. Except on the first one. For the first one, 5 divided by x, are y'all okay with rewriting that as 5 times the integral of 1 over x dx? Remember, you can always pull a number in or out of an integral. You can't pull a variable, but the number is fine. So 5 times the integral of 1 over x is 5 what? ln x plus c. Put that x in absolute values. Yeah, you actually have to put those absolute values. No. And you're going to do it so much that the absolute value is going to become second nature. So if I were to give you a pop quiz tomorrow and you left off the absolute values, I'd probably be okay with that. But try not to do that. All right, number 2. When we have fractions that we're integrating, the first thing we're going to look for is whatever is on the bottom, can we make the derivative of that fit the top? And we can do that by U-Substitution. So we're going to let u equal the bottom. So u is 5x plus 3. What's du? 5 dx. So can we make the top into 5 dx? Absolutely. Stick a 5 in there and therefore a 1/5 outside. So we have 1 over u, and then the 5 dx is our du. So what's the integral of 1 over u? ln u. So 1/5 ln absolute value of u plus c. And then don't forget to substitute your 5x plus 3 back in. The good news is I saw very little of that on your test, forgetting to substitute back in. So that's good. Which I have the first parts of your test graded, but I don't have the second part. I'll have it by Monday. All right, at this point, when you see a fraction, start by letting u equal the bottom. So number 3, let u equal x squared plus 6x. So what's du? 2x plus 6 dx. Can we make the top into 2x plus 6 dx? Yep. Multiply the whole top by 2. Therefore, have a 1/2. In the next week or so, I'm going to introduce different techniques, but right now you will be able to make the top into the derivative of the bottom. So 1/2 1 over u du. 1/2 ln absolute value of u plus c. 1/2 ln absolute value x squared plus 6 plus c. Thank you. 6x. Now, if you see, like if some of this, I think a lot of you very quickly will be able to kind of skip the U-substitution part. As long as you're honest with yourself and you recognize when you really need to go through the U-substitution and when you can just kind of visualize it and get to the end, I'm okay with that. Just don't try and overdo it. Like once you get to this point right here where we put the 2 on top and the 1/2 outside, then whatever's on the bottom, we've got the derivative of that on top. So therefore the integral is the 1/2 that was outside, natural log of the bottom plus c. Let's kind of try and do that with number 4. What's the derivative of tan? Secant squared. That's exactly what's on the top. So this integral is the natural log of tan x plus c. So anytime you've got a fraction and whatever's on the bottom, if you have exactly that derivative on top, or even if you can kind of manipulate it and put a coefficient outside, then your integral is the natural log of the bottom. Number 5. Anybody have any thoughts? Like ux plus 1? Okay, let's try it. So what's du? dx. Okay, I don't have a problem with that. Solve for x. Very good. X is going to equal u minus 1. All right, so on top, what will we have? 2u minus 2? Or what about this 2 that's on top? What about pulling it out in front? How would you feel about that? Okay. Pull that 2 that's on top out in front, and then we just have x, which is u minus 1. And what's the bottom going to be? Yeah, I just haven't gotten to the du. So we've got u squared on the bottom, and then dx is just du. Did I lose anybody? Okay. All right, what should I do next? Separate. Good. And this is looking like a problem that you could have done on this last test. However, when we separate the numerator, what do you get? 1 over u minus 1 over u squared. All right, now the 1 over u I kept as the 1 over u as opposed to doing u to the negative 1. But the 1 over u squared, I wrote it as u to the negative 2. Why? Okay, the 1 over u is a natural log. But the u to the negative 2, I'm just going to use the power rule. All right, so the 2's out in front. 1 over u is, the integral is natural log of u in absolute value. And then the integral of negative u to the negative 2 is plus u to the negative 1. And it doesn't really matter where you put your plus c. What? All right, I'm going to distribute my 2 and plug in my x's. So 2 natural log absolute value of x plus 1 plus x plus 1 to the negative 1, another 2 in front of that, plus c. Eddie, you okay? Okay. Looks like you were rubbing your forehead. Okay. This too? Uh-huh. No, well, are you talking about this 2 right here? You're trying to take the derivative. Integrate, you bump the exponent up by 1. So negative 2 is going to go up to negative 1. Okay, number 6. What do you want to let u be? X squared plus what? Right. So du is 2x dx. Can I make that work? Yep. 2, 1/2. So 1/2 integral 1 over u du. Now, it's a definite integral. So since I've switched to u's, I need to switch those limits of integration. So this bottom limit of integration started as a 0. When x is 0, what's u? 1. And when x is 3, what's u? 10. Okay, so 1/2 integral of the natural log of u. I don't need the plus c because I'm evaluating it from 1 to 10. Which one do I plug in first? The 10. So 1/2 natural log of 10. Do I need absolute values around the 10? No, 10's a positive number, so that's cool. Minus 1/2 times the natural log of 1. One of those two I can simplify. What's the natural log of 1? 0. So 1/2 ln 10.